Hello students, welcome to the second session of our second module. So students, in the previous session we have discussed the idea called Poisson's ratio mu. Mu is nothing but lateral strain by longitudinal strain, right? Lateral strain by longitudinal strain, right? So lateral strain can be written as mu times longitudinal strain. Okay, so if the longitudinal strain is a tensile strain, then lateral will be compressive, so there should be a minus. Okay, so you should add a minus here. Okay, because if lateral strain is compressive, longitudinal will be tensile. So if we are we are stretching lateral longitudinal ways, then there will be compression in lateral direction. So you can write, suppose, so here now we will learn the relationship between stress and strain in 2D or plane. Okay, so in plane condition, plane stress and plane strain, Hooke's law for plane stress and plane strain. So relation is nothing but Hooke's law itself. Hooke's law. So Hooke's law in case of plane stress and plane strain. The students, if this is a plane, so I am applying some. So if there is some force, there is some stress in this direction and some stress in y direction, sigma 2 in y direction, sigma 1 in x direction. So these are normal stress. Okay, normal stress. Okay, so students, if there is a longitudinal stress in this direction, what will happen? It will extend in this x direction, so there is an extension here. Okay, but there will also be a compression in this lateral direction. So an extension in longitudinal direction, at the same time compression in the lateral direction, right? So that is why we are including the term due to sigma 1 there will be a strain epsilon 1 in x direction or longitudinal direction. Longitudinal direction, right? Also a mu sigma 1 in lateral direction. So both this is happening due to sigma 1. So epsilon 1 in longitudinal direction, mu epsilon 1 in lateral direction, Okay, similarly due to sigma 2, an epsilon 2 in longitudinal means in y direction, minus mu epsilon 2 in x direction, right? So total strain in x direction can be x direction and y direction. How to find? I will show you in this figure. Okay, so epsilon 1 in x direction due to sigma 1 and a minus mu epsilon 1 in this direction, okay, due to sigma 1. Similarly, epsilon 2 in this direction and minus mu epsilon 2 in x direction. So in Actually, in x direction we have epsilon 1 minus mu epsilon 1. Sorry, mu epsilon 2. Mu epsilon 2. Right? Similarly, epsilon 2 minus mu epsilon 1. Right? So this is the sum in x direction, this is sum in y direction. So we can substitute, we know that sigma 1 equal to, sigma 1 equal to E into epsilon 1, Hooke's laws. So gives epsilon 1 is nothing but sigma 1 by E. Similarly, epsilon 2 will be sigma 2 by E, where E is Young's modulus. Now substituting here for all these values, you can write total strain in epsilon in x direction can be sigma 1 by E minus mu sigma 2 by E. Similarly, epsilon y is sigma 1 by sigma 2 by E minus mu sigma 1 by E. So this is the relationship of stress strain relationship in plane or 2D. So this is how we write stress strain relationship in 2D. Similarly, in 3D, in the 3D case of 3D case, if this is our a cube, so we have sigma 1 in this direction, sigma 2 in y direction, and sigma 3 in z direction. So this is x, y, z. So here in x direction, epsilon x can be written as sigma 1 by E minus mu sigma 2 by E. But since this is 3D, one more term will be there, mu into sigma 3 by E. Similarly, x y equal to sigma 2 by E minus mu sigma 1 by E minus mu sigma 3 by E. Similarly, epsilon z equal to sigma 3 by E minus mu sigma 2 by E minus mu sigma 1 by E. So this is the relationship, Hooke's relationship between stress and strain in the case of 3D, 3D, right? 3D volume, 3D space. Suppose we have the same, suppose we have the same 3D block, a prism, rectangle prism, but I am having only stress in this direction only. There is no stress in x or y direction. So how will you calculate the strain, volumetric strain, or linear strain in x direction? In x direction, epsilon 1, right? Epsilon 1 can be calculated. How can you calculate, or wait, if the if this length is, so this breadth is b, this height is h, okay, this is length l, okay, total volume will be lbh, right? V equal to lbh. So here I am applying stress in one direction only. So linear stress epsilon 1 will be delta L by L. If this is increasing in x direction, delta L by L, it can be written as sigma by E, or sigma 1 by E, right? Sigma 1 by E. So if this is getting stretched in x direction, there will be compression in this direction and this direction. Okay, this is sigma 2 or this is sigma 3. So what will be the compression? So the longitudinal stress is in x direction only, because we have only one sigma. right? One sigma is only there, or one load is only there. So it can be written as sigma by E or sigma 1 by E. Similarly, lateral strain, so this is epsilon 1. Lateral strain sigma epsilon 2 is equal to minus delta B by B. A change in length. This okay, so this will be delta H by H. So the H is the height is getting reduced. Similarly, another lateral strain, epsilon 3 will be minus delta B by B. Here breadth B is getting reduced. Okay. So epsilon 1 is sigma by sigma 1 by E. Epsilon 2 will be delta minus delta H by H, and its value will be minus mu, since it can be related with the Poisson's ratio minus mu sigma 1 by E, and epsilon 3 will be minus delta B by B, and its value will also be equal to minus mu sigma 1 by E only. Okay. So if there were, so students, here only one load in one direction only, load in one direction only. So here we took a load in all the three directions. So there are three stresses. Here only one stress. Students, how to find volumetric stress? Actually, if V is LBH, if there is a change in volume V plus delta V, then there will be change in delta L, P plus delta V, and change in everything, all the three parameters, right? So this, if you open the bracket, you will get LBH into, and if you multiply it, you will get delta L by L. I am taking L, B, and H common from all the three different terms. So it will be 1 plus delta B. So I am taken a L from here. I am taken a B from here. I am taken a H from here. So LBH is common, and equation will become like this. Okay. So what is this? This is V itself, right? This is V itself. So if you open the bracket, you will get V plus delta V equal to V into 1 plus delta L by L plus delta V by B plus delta H by H, and many terms will get cancelled because delta L by L into delta B by B, such terms will be there. You just neglect those terms because delta into delta will be very small in number. So smaller terms are neglected. So this equation will become like this. Okay. So this will become V plus delta V equal to multiplying V plus V into delta L plus L delta B by B delta H by H. Okay. So this V and this V cancel. So we get delta V equal to V into 1 delta L by L plus delta B by B plus delta H by H. So I am taking delta V by V is nothing but delta L plus L plus delta B by B plus delta H by H. Okay. So what is this? Change in volume by original volume. That is volumetric stress. So volumetric stress will be equal to delta L by L plus delta B by B plus delta H by H. So students, here you have to note down that delta H by H is epsilon 2, delta B by B is epsilon 3, and delta L by L is epsilon 1 only. So students, you can write epsilon V, volumetric strain. Volumetric strain. is nothing but delta v equal to, sorry, epsilon v equal to epsilon 1 plus epsilon 2 plus epsilon 3. Epsilon 1 is sigma 1 by e. Epsilon 2 is minus mu sigma 1 by e. Epsilon 3 is again mu sigma 1 by e. Right? So this here sigma 1 can be written as taken as common. Sigma 1 by e is taken as common. So what is remaining? So this value is remaining. Okay. This value is remaining. So students, in the previous in this, okay, in this 3D, if the body is having load in all three direction, we can write ex, ey, ez, or even epsilon 1, epsilon 2, epsilon 3 like this only, right? Because we have three. So students, I am in this. So the case where uh, we have stress in all direction. So this all with this, okay, here sigma 1 sigma 1, sigma 2 sigma 2, sigma 3 sigma 3. Here epsilon 1 epsilon 1 is epsilon x, or epsilon 1 or epsilon x can be written as sigma 1 by e minus mu sigma 2 by e minus mu sigma 3 by e, right? So here epsilon 1 is written like this. And epsilon 2 here is, it is sigma 2 by e minus mu sigma 1 by e minus mu sigma 3 by e. Epsilon 3 is sigma 3 by e minus mu sigma 1 by e minus mu sigma 2 by e. So students, in this case where we are having three mutually perpendicular stress, epsilon v is always epsilon 1 plus epsilon 2 plus epsilon 3, right? So epsilon 1 plus epsilon 2 plus epsilon 3 means we have to add all this. So 1 2 3, we have to add 1 plus 2 plus 3, all the three equations. So you will get epsilon v equal to, if you add, you will find it as sigma 1 plus sigma 2 plus sigma 3 by 3 into 1 minus 2 mu. So you will get the equation like this. Okay. So if you add all these three equations, sigma 1 plus e plus sigma 2 plus e plus sigma 3 plus e, sigma 3 by e, here minus mu sigma 2 by e minus mu sigma 3 by e minus mu sigma 1 by e. If you add, you will get equation like this. Sorry, this is not 3. This is e 1 minus 2. So you will get an equation like. So if sigma 1 equal to sigma 2 equal to sigma 3 equal to some sigma, all the perpendicular normal stresses are equal. So such a case is hydrostatic pressure. Hydrostatic pressure. Such case is hydrostatic pressure. Equal pressure in all sides. Equal pressure in all sides. So in such a case, delta V by V or epsilon V, volumetric stress can be written as 3 sigma by E into 1 minus 2 mu. Because sigma 1 plus sigma 2 plus sigma 3 has become 3 sigma. Okay. So in that case, sigma 1, epsilon 1 will be equal to epsilon V equal to epsilon 1 plus epsilon 2 plus epsilon 3, or it will become 3 epsilon because sigma is same. So sigma v equal to epsilon v equal to 3 epsilon 3 epsilon equal to 3 sigma by e into 1 minus 2 mu, right? So here epsilon will become sigma by e into 1 minus 2 mu, right? Right. So how to find the maximum possible value of Poisson ratio? So if you take this value E into epsilon by sigma equal to 1 minus 2 mu, right? So the previous this equation can be written like this. So since this value has to be positive, right? Because strain is positive, epsilon E should be positive, sigma is positive. So if sigma is positive, epsilon should also be positive. So 1 minus 2 mu should be always greater than a positive value. So mu will always be greater than half. Okay. Sorry. So 1 minus 1 should be greater than 2 mu, right? So mu should be less than half. So this is how. So the value of Poisson's ratio will always be less than half. Students, we have already discussed in the previous class that epsilon v is equal to sigma by k, where k is bulk modulus, right? But epsilon v in case of equal pressure or hydrostatic pressure, epsilon v is nothing but 1 minus 2 mu into 3 sigma by e, right? 3 sigma by e. So this equation can be equated. 1 is equal to 2. 1 is equal to 2 means sigma by k is equal to 1 minus 2 mu 3 sigma by e. So if you cancel this, you will get e equal to 3k 1 minus 2 mu. So this is the relationship between Young's modulus and bulk modulus. E equal to 2k 1 minus 2 mu. Relationship between Young's modulus and bulk modulus in case of equal pressure on all sides of element. So this is how calculate we develop the equation for a relationship between epsilon and not epsilon, Young's modulus and Poisson's ratio and bulk modulus. So E, K and mu are related by this particular equation. Sorry, this is 3, okay. So here you can also write k equal to E by 3 1 minus 2 mu. It's also a very important equation. Students, in the previous class I have shown you the constitutive relationship between sigma and epsilon. So this is the matrix called constitutive matrix or stiffness matrix. And similarly, in the reverse direction, epsilon is equal to compliance matrix or flexibility matrix into sigma matrix. So students, for an orthotropic material, you can write this gamma epsilon x epsilon y, epsilon z, gamma xy, gamma xz, gamma, so gamma yz, gamma xz. So this is strain matrix equal to compliance matrix or flexibility matrix into sigma matrix, right? Or normal matrix or stress matrix, sigma x, sigma y, sigma z, tau xy, tau yz, tau xz. So students, so I have already told you that this matrix will be a function of all the elastic constants, right? Like modulus of elasticity, modulus of rigidity, and bulk modulus, and what? Poisson's ratio. So in the case of Hooke's law, stress is related to strain according to one dimensional Hooke law, like sigma is equal to E into epsilon. But here, when it comes as a stress tensor or stress matrix, അതായത് സ്ട്രെസ് ടെൻസറോ സ്ട്രെസ് മെട്രിക്സോ ആയിട്ടാണ് നമ്മൾ ചെയ്യുന്നതെങ്കിൽ ഈ മാത്രമല്ല വരിക, എല്ലാം വരും. മ്യൂ വരും, ജി വരും, ടോ വരും. അപ്പോൾ ഈ സി എന്നുള്ള ഫംഗ്ഷൻ, സി എന്നുള്ള മെട്രിക്സ് ഇതിൻ്റെ ഒക്കെ ഒരു ഫംഗ്ഷൻ ആയിരിക്കും. അപ്പോൾ നമുക്ക് ഇപ്പോൾ ഓൾറെഡി കുറച്ച് പഠിച്ചുകൊണ്ട് സി മെട്രിക്സ് എന്നുള്ളത് ആക്ച്വലി ഇങ്ങനെയാണ് വരിക. 1/EX minus mu xy EY minus mu xz EZ. ഇതെങ്ങനെയാണ് വരുന്നതെന്നുള്ളത് നിങ്ങൾ പഠിക്കണ്ട, ശരിക്കും ഇത്ര ടേംസ് വരും. മൈനസ് മ്യൂ xy EX 1/EY minus mu yz EZ 0, 0, 0 minus mu xz minus mu yex minus mu yz by ey minus mu 1/ez 0, 0, 0 0, 0, 0 1/gx y 0, 0 0, 0, 0 0 1/g yz 0 again 0, 0, 0 0, 0 1/gx. So the last term will be. So this is how the complex matrix looks like. So you know why this mu xy mu xz by mu by e terms comes, right? Because you can see here in this all this equation there is mu by e terms. So that is how epsilon 2 is connected to sigma 2 and sigma 1. So all are interrelated. Every terms are interrelated. So there is 1/e term, mu by e terms, and later you can also see 1/g terms coming into play. അപ്പോൾ അതുകൊണ്ടാണ് ഇതിൻ്റെ എല്ലാം ഒരു കോമ്പിനേഷൻ ആയിക്കുന്നത് ഈ കോൺസ്റ്റന്റ് മെട്രിക്സ്. ആ കോൺസ്റ്റന്റ് മെട്രിക്സ് വഴി സിഗ്മ ടെൻസറും അല്ലെങ്കിൽ മെട്രിക്സ് സ്ട്രെസ് മെട്രിക്സും സ്ട്രെയിൻ മെട്രിക്സും കണക്ട് ചെയ്യുന്നതിനെയാണ് നമ്മൾ എന്ത് പറയുന്നത്? കോൺസ്റ്റിറ്റ്യൂട്ടീവ് റിലേഷൻ എന്ന് പറയുന്നത് റിലേഷൻഷിപ്പ്. അപ്പോൾ അതെങ്ങനെയാണ് മെട്രിക്സ് എങ്ങനെയാണ് എഴുതുന്നതിൽ ഡെറിവേഷൻ പഠിക്കേണ്ട, സംഭവം എങ്ങനെയാണ് ആ ഒരു ഐഡിയ നിങ്ങൾ മനസ്സിലുണ്ടാവും കേട്ടോ. Okay, so with this we will stop this particular session. Thank you.